Hey scholars, I hope this video finds you well. Today we're going to be talking about reflections in the coordinate plane. We're going to be talking about how reflections work, and then we're going to learn some rules for them so that we can perform them really quickly. So anyway, make sure you're taking good notes. Follow along with the slides that I've attached on Google Classroom. I'll be teaching from my board, and if anything's difficult for you to see, then make sure you're referring to those slides. But let's get going. So check this out. A reflection is a transformation in which a geometric figure is reflected across a line, which we call the line of reflection. And it creates a mirror image, just like if you looked in the mirror and you see your own reflection. So each point of the image is the same distance from the line of reflection as the pre-image. So here we have a horizontal reflection. Let's say this is the pre-image. It's hard to tell which one is the pre-image, which one's the image, but I'll start right here. Here's the pre-image. Let's say it's triangle A, B, C. Well, it's going to reflect to become triangle A prime, B prime, and C prime. Now, the distance from point A to the line of reflection, let's just say it's 1 inch. Well, the distance from A prime to that line of reflection would also be 1 inch. Same for B and B prime. If B is, 3 inches away from the line of reflection, then B prime would also be 3 inches away from that line of reflection. All right, so now here we see a vertical reflection. So you can see that the line of reflection is actually a horizontal line. So we call it a vertical reflection when it reflects from up to down, or down to up across a horizontal line, and we call it a horizontal reflection when the line of reflection is vertical, going up and down. The pre-image to the image is flipping across horizontally. All right, now let's try doing some reflections in the coordinate plane. So we want to plot the image of this figure, triangle QRS, according to the following rules. So we want to reflect it across the line y equals -1, and then we're going to reflect it across the line x equals 3. So first I'm going to draw the line y equals -1. So I'm going to find -1 on the y-axis. So look at the y-axis, the vertical axis, here's -1. And I'm just going to draw a dotted line. And you can draw a solid line if you want to. I'm going to make a dotted line here, or a dashed line. And so then what I'm going to do is I'm going to remember, what do I know about reflections? Well, I know every point of the pre-image is the same distance from the line of reflection as every point of the image. So if I want to find Q prime, so I'm going to look at Q, and I'm going to see that Q is exactly 1 unit away, so 1 unit away from the line of reflection. So then I'm going to go on the other side of the line of the reflection, and I'm going to go 1 unit away, and I'm going to plot this point, and it's going to be Q prime. So you see Q and Q prime are the same distance from the line of reflection, 1 unit. Now I'll do the same thing for R to find R prime. Well, R is also 1 unit away from the line of reflection, so I'm going to go 1 unit away on the other side of the line, and I'm going to label that R prime. Be sure to label when you're plotting these points. All right, now the last point I need to do is find S prime. So point S is 1, 2, 3, 4, 5 units away from that line of reflection. So then just on the other side of the line of reflection, I'm going to go 5 units to find S prime. So 1, 2, 3, 4, 5 units away from that line of reflection. So this is S prime. Now, lastly, I'm going to connect the dots. And there you go. We have performed the reflection across the line y equals -1. Now, next, we're going to try to reflect this figure across the line x equals 3. So I'm going to find 3 on the x-axis. So 3 on the x-axis, and I'm going to draw a vertical line through that. All right. So now I see that point R is actually on that line. It's 0 units away from that line of reflection. So I'm just going to plot a point right there. I mean, it's just on top of R, and that's also going to be R prime. So because R is on that line of reflection, R prime will have the same coordinates as R. So now, I'll just do the same thing I did earlier with Q and S. Point Q is 1, 2 units away from the line of reflection. So then I'm going to go on the other side of the line, 1, 2 units away there. And that will give me Q prime. Point S is 2 units away from the line of reflection. So S prime is going to be 1, 2 units away from the line of reflection. So there we go, we have S prime. And then again, don't forget, we need to connect the dots, connect those points. And there you go. So now we're going to reflect triangle QRS in a couple other ways. The first rule says to reflect it across the y-axis. So the y-axis right here is this vertical axis. We're just going to reflect it horizontally across that vertical line of reflection. So point Q is 1 unit away from the y-axis. So then I'm just going to go 1 unit away on the other side of the y-axis and get point Q prime. Point R is 1, 2, 3 units away from the y-axis. So then we're going to go 1, 2, 3 units on the other side of the y-axis to get R prime. Point S is 1 unit away from the y-axis, then we're going 1 unit over on the other side to get point S prime. And then connect the points. All right. Now, I'm going to keep this figure on the board, and then we're going to reflect triangle QRS, the original, the pre-image, right, across the x-axis. So now it's going to reflect vertically across that horizontal line of reflection, the x-axis. So point Q is 2 units away from the x-axis, so it's 2 units away on the other side. So there we got Q prime. Point R is also 2 units away from the x-axis, so R prime is going to be 2 units away on the other side. Point S is 6 units away from the x-axis, so we're going to go 6 units away here. And we'll have S prime. Now, these should actually, since we already have Q prime, R prime, and S prime, I actually should have been naming these Q double prime. So we'll have like 2 prime. They look like 2 little apostrophes. Let me fix that. Q double prime, R double prime, and S double prime, since we already had Q prime, R prime, and S prime. Okay, so learn from my little mistake right there. When you already have primes for one figure, you need to start doing double primes for the next figure. All right. Now, if I were to compare the coordinates of Q, R, and S to Q prime, R prime, and S prime, well, when it reflects across the y-axis, like it did here, the x coordinates are going to become negative. So check this out. You see what I'm saying? Q, so when we reflect across the y-axis, Q had coordinates of 1, -2, and Q prime had coordinates -1, -2. So the x value became opposite. It went from 1 to -1 when it reflected across the y-axis. When we reflect across the x-axis, so let's compare Q, which was 1, -2, it's Q prime. Sorry, Q double prime. So we got Q double prime when we reflected across the x-axis. So Q is 1, -2. Well, when you reflect across the x-axis, the y value becomes opposite. So the coordinates of Q double prime are 1, +2. So when we reflected across the x, the y value became opposite, went from -2 to +2. And when we say it becomes opposite, it means it changes signs. It goes from negative to positive to negative. Now take a look at these formulas that you're given here. The first one, you're given a reflection across the x-axis.
Now, look in the little greenish yellow box. So when you reflect across the x-axis, the y value becomes opposite. And you can see that in this formula. All right, so we have the original point, x, y. Well, it becomes x. It looks like negative y, but let's say x the opposite of y, because that helps us to remember if a number becomes opposite, if it's positive, it becomes negative. If it's negative, it then becomes positive. Okay, so you can see that when you reflect across the x-axis, the y value becomes opposite. When you reflect across the y-axis, the x value becomes opposite. So look at these graphics, try to understand, look at the coordinates, compare the coordinates of the pre-image to the image, and I think that will help you to get those rules down and understand it at a more conceptual level. So take some time to write down those rules and look over it. Now let's apply those rules that we just learned. So this problem says triangle STU has vertices at S 3, 4, T 3, 1, and U negative 2, 1. Well, what are the coordinates of S prime, T prime, and U prime if it's reflected across the x-axis? Well, when we reflect points across the x-axis, the y value is going to become opposite. So we have S is going to become 3, negative 4, changing the sign of the y value, and that's going to be S prime, I should say. And then we have T prime, which is going to be 3, negative 1. The opposite of positive 1 is negative 1. And then U is going to be negative 2, negative 1. All right, so now if it's reflected across the y-axis, we'll have S prime would be negative 3, positive 4, because when we reflect across the y-axis, the x value becomes opposite. So negative 3, positive 4 would be S prime. T prime would be negative 3, positive 1. Again, the x value is becoming opposite. And then U prime, well, the opposite of negative 2 is positive 2. So unlike the other values we've looked at, this is negative, and it's going to become positive. So positive 2, positive 1. The y value stays the same. The x value becomes opposite. A couple more rules for reflections. So here's an interesting reflection. We have a reflection of the points x, y across the line y equals x. So you end up swapping the x and y values. You see how the y value moves into the x spot, and then the x value moves into the y spot. Basically, they just swap. So you can look at this triangle here. Look at point A with me. You see the pre-image, point A, is negative 4, negative 2. Well, the image, when it reflects across that line, y equals x, A prime has coordinates negative 2, negative 4. So A goes from negative 4, negative 2 to A prime, which is negative 2, negative 4. The x and y values just swap places when you reflect across y, the line y equals x. A way I remember that is when I see y equals x, I draw a little line right here showing me that they're going to swap. Now, when a point is reflected across the origin, both the x and y value become opposite. The x and y values. So it's like we reflected across the y-axis and the x-axis. So when you reflect across the y-axis, the x value becomes opposite, and then when you reflect across the x-axis, the y value becomes opposite. So that's what happens when you reflect across the origin. It's like reflecting across the x and y axis, and both the x and y value become opposite. So now let's try these problems. Triangle ABC has vertices A 3, 2, B negative 3, 2, and C 3, 5. What are A prime, B prime, and C prime if the triangle is reflected across the line y equals x? Well, remember, y equals x, we're just going to swap the x and the y. So if I swap the x and the y of A, I get A prime, which is 2, 3. B prime is going to be 2, negative 3. And C prime will be 5, 3. So just swapping the x and y values. So when the triangle is reflected about the origin, remember both of them are going to become opposite. Both the x and y values will become opposite. So A prime is going to be -3, -2, so they both become opposite. B prime becomes +3, -2. They both change signs, right? And then C prime, -3, -5. So I hope this video was helpful for you. I know it's a little bit lengthy, but hopefully you learned a little bit and were able to get some of those rules down. Come to class ready to practice applying those rules and to perform reflections. And I guess I'll see you then. Thank you, collegiate scholars.